Hi folks, my name's Bob Spur. I'm one of the machining mentors in here, and I also do safety mentoring. This is my son Connor, so you'll notice we're not observing safe distancing here because, well, we live in the same house, so we don't need to observe safe distancing here. So just to preface with that. We're gonna take a quick look at a machine called a lathe. A lathe is an exceptionally versatile machine that, in difference to the milling machines, this actually spins the part we're working on rather than the tool. And you can do a multitude of different operations on a lathe, some that you would never even think are possible to do on a lathe. I mean, that square was completely turned on a lathe, and you would never think you could turn a square. That's sort of an advanced thing. We'll get to that. You know, you want to ask later, we'll talk about that. But right now, we're going to go through a simulation of an operation we kind of do on a regular basis, which is an axle shaft. And we use standard half-inch hex stock. We're going to use a 3-jaw chuck here, but we also use a system called 5C collets, which hold it in a little different way. But the 3-jaw is commonly used and a little bit more complicated, so we'll look at it that way. And if you can master this, you'll be good with 5C collets. So Connor, why don't you go? You've got the chuck key in your hand,
right here,
which is the only place the chuck key belongs. If you're moving something, you always want your hand on it. If your hand's on it, you're not going to take off with it. So the machine's locked out. Why don't you go ahead and slide that part in.
Yeah, slide. This is loose already.
Yep.
So we can put this in.
Something interesting to note on this, because this is 6-sided, a multiple of 3 for the chuck. Connor, start tightening it up, and as you tighten it, you want to rotate that part around. And what that'll do is make sure you're not catching it somewhere. You're actually getting it on the flats.
This is turned, and I cannot turn this because we're on the flat sides rather than the vertices. If we're on the vertices, this would turn. Am I not mistaken?
You're correct.
Alrighty then.
You're correct. So make sure that's good and tight.
Yep, this is tight. Now it's definitely tight.
All right, so you're prepared to run it. So where does the chuck key belong?
On the bench. Do not put this here, or it may fly and hit you.
Right.
We don't want that.
Right. So the first thing Connor's going to do is tradition with most lathe things, is he's going to face off or machine flat the front face that he's working on. So this is designed to go on the back side of the tool post. The tool post we use that he's putting the equipment in now is an Aurora. That's tight, so just pull the lever back.
All right.
Is what's called an Aurora style tool post. This is a Taiwan made version of it, but honestly the Taiwan versions are just as good as Aurora's own brand. And it allows for a quick change. We always, once it's set up, know where that tool is in height relation. Connor, back it out, and let's face that off.
Okay.
And back out a little bit. That's good. Right, turn your lathe here. So turn the power back on. Excellent.
And then we're gonna go forward.
Yep. Go into forward mode. Go in. Right there. Scroll in on your table. On your cross feed. Perfect. Now you're somewhere in the middle. So come over with this very gently until it just touches.
There you go.
Now back out with this. All the way. There you go. All right. So now we know where we are in relation to the front. The direction of the movement of the cross slide towards the head is the Z-axis. So we're going to zero it just so we know how much he's taking. Z, 0, enter. Now, back off just a little bit on your cross slide. Perfect. And come over. Let's take 10 thousandths off.
All right.
Oh, that's more. So 1.0. Close enough. When we're down in here, we're in the 10 thousandths of an inch, and we don't worry about that here. Now, run your cross slide in. Yep, you're good. Just keep going. Perfect. And now you can go this way on Z and shut the lathe off. What Connor has done is now we have a nice clean machined face here. There's a little divot still in the center, which is fine. There's a nice clean machined face. The next thing he's going to do, take that tool out.
All right.
No, yeah.
There we go.
And let's put this guy in.
Backside still?
Nope. This one's designed to go on the front side.
All right.
So if you look at the Aurora posts, they will do kind of a left and a right-handed tape dovetail, and that just sets where the tool's basically set up to run. Tighten that down.
Yep, already done so.
Now what we're gonna do is come and you wanna break this edge. Just put a slight chamfer on it. So back out and come over. Back, there you go, back up a little bit more, that's good. Your Z is no longer accurate, but that doesn't matter because this is more of an eyeball operation. We're just breaking the edge on it.
All right.
So you're not touching, go ahead and turn your lathe on.
Off.
And come over with your table. Just a little bit more. Perfect, and now you can back off again. And shut the lathe off. So, not quite there, let's take just a little bit more, do that again. Bring it right in. There you go, that's good. Now back it off and shut the lathe off. Now what Connor's done is he's rounded over the edge on this so that it's easier to slide it in a hole, because you gotta figure this is going in, this was for a different operation, but it will be a hole like the hex that's in the middle of this. This was a spool from a few years ago. Being chamfered, it just makes it easier to slide in. And it makes it so it doesn't cut you as easy. So now what we'll do, Connor, take that out.
All right.
And we're gonna center drill and tap this hole. Grab your center drill.
Is right there.
Let's make sure we get the right side in. Yeah, that's good.
Going the right way? Yes, I am.
So the drill chuck on the lathe and the tailstock is a keyless chuck, just like we have over on the other side.
I got that one.
Back your cross slide out a little bit because it's in the way. That should clear.
And it does.
Yep, slide your tailstock down closer to your workpiece. Now you're gonna have to bring your cross slide, your table this way, your apron this way. That's good, that's plenty. Back up a little bit and reach back here and lock it. Lift up. What you've done there is this is now fastened in place. One of the keys with a lathe, like other machinery, is you don't want a lot of hangout for your workpiece because it's easy to deflect. So we will try to keep it as short as possible. All right, Connor, go ahead and turn the lathe on.
All right.
Spin in, and this is, we're just trying to put a center pilot hole in there. Now I realize this already had one, we're using a piece of old stock. A little bit more, you just run it in. There we go. There you go. A little bit more. That's good. All right, you can back it out. We have a pilot. And shut your lathe off. You probably have to back your tailstock up a little bit. We'll put a 0.149 inch drill in there, which is the tap size for 1024.
So that comes out. In comes the tap drill bit. There we go. That tap bit is now back in. Let's bring this back.
So, come on in. If you notice up top here, back up just a little bit. Let's get to like right about there. There's line graduation. Shay, if you can see that. This actually has a ruler, a scale on this, so you can know how deep you're going in. That does not have a digital readout. So go ahead and lock your tailstock. You're fine, that's good.
All right.
Turn the lathe on. Spin your drill in until it just barely touches.
Right there.
Now make note of what your scale is on your tailstock.
All right, 1 point.
It's 0, ½ inch, inch. So you're just shy of 1.5 inches there. You're actually, that would be 1.25 inches. This would be a 1/16 of an inch graduations on this. I had to look myself and remember what the graduations are. It's every one of those lines is a 1/16 of an inch.
All right.
So 0.62 for every one of those lines. Okay, go ahead.
Try this again.
So run it into 2 inches deep.
Gotcha.
Total.
There's the one.
One of the keys to drilling on a lathe is if the chips are still coming out well, keep feeding it. You're doing good.
we're a little over 1 tool
Back
inch.
it out. Back it out.
Yep.
There you go. And you can shut the lathe off. Back the tailstock up.
Yep.
Oh, well, you don't need to go all the way. That's good.
Yeah.
That's fine. So now we're going to thread it. This is a 1024 tap on a T-handle. One of the many ways you can hold this. What Connor's going to do is, you can see threads on here that correspond to a 1024 bolt. He's actually going to cut those threads into the end of this shaft so we can put a bolt in the shaft. So take that, give it a little bit of lube, a little bit of oil.
And oil this tap right here.
Yep, just a touch. Doesn't need much.
Oh, there we go.
Okay, that'll work. To run this in nice and straight.
Yeah.
Okay, it's easy to break taps if you run them in crooked. We've all done it. So you got to give it a little bit of a push to get started. You gotta hold some pressure on it. There you go, keep going. Good job.
Oh.
Keep going, you gotta be very steady with it. No, one-handed. So if you use 2 hands on it, you're naturally gonna wanna torque it around more and move it. Good job, Connor. Okay, now give it an 1/8 of a turn backwards. Good, you just broke the chip, that's good, and keep doing that. Give it like a turn in, bring it back an 1/8 of a turn. Good job, and do it again, and just keep doing that until she gets to the bottom. Now the tap we're using here is not designed to get all the way to the bottom. It's not a bottoming tap, but for our purposes, it gives us a good indication of what we're trying to do. All right, that's good, Connor.
So back it out.
Back it out.
All right, there we go. So we've tapped that hole successfully. No
Okay.
broken taps. Put that in there.
Okay, so that side is done. Lathe is saved. Go ahead and take that out. The only place this chuck key wants to spin completely around is right about there. Because we have a safety here, and otherwise it hits on the gearbox
There
of
we
the lathe.
go.
Perfect, now
Okay.
flip it around and put it in and tighten it down.
On the side, we are.
There you go.
There we go.
Good job. This side is already finished, but what we're going to cut in it is a groove. And the reason for that groove is we commonly use a snap ring to hold a wheel in place or an axle in place. This one's actually a little on the loose side, so it must have been something someone was practicing with. But we'll cut a groove in there, and then this ring can just snap onto it and hold the wheel in place, hold
So
the
this
axle in
is
place.
typically a drivetrain axle as well, where these can experience heavy loads. This
Right.
is why I want to have that clip on it.
Exactly, exactly. So to cut this, we're going to use a parting tool. There's your parting tool. Go ahead and put it in. Handle forward.
There we go.
There you go. So all that's doing is activating a cam. As you move around, you could just keep spinning it, then the lobe's going to go in and out as you go around. So it works that way. You can go forward, backwards, around. All right, come on down. And stop there. And I want to show you a trick.
Okay.
We want to know how far down this part is. So we're going to kind of eyeball a line up, grab a scale, just keep coming over till it just barely can't feel it. That is lined up so close that we are well within our tolerance. Now,
Oh, yeah, definitely.
if we come up here, 0 to Z, so Z0, enter. Back out so it's clear. Back out with this so it's clear, just a little out, there you go. Now come over 062, so 0.62. Now 0 your Z again. So now, when the drawing shows that we want the leading edge, this forward edge of the slot, let's call it 125 thousandths in. We now know where that slot goes, okay?
Gotcha.
Actually, you know what? We had that slot already before we 062'd it. So, we zeroed it there. right there at 062. It's been a whole season since I've been in here,
Yeah.
you realize, kids. I had to think about it myself. We're at 062 there.
We're gonna
Zero,
do that
enter.
again.
Come down to 125. 0.125.
Yes, I probably want to do so close.
You're fine.
Oh,
Perfect, right
hello.
there. You are now, your edge, your outside edge here is 125 thousandths of an inch back from this face. So that tells us we're gonna leave 1/8 of an inch or 125 of shoulder on there. Whatever the designers call out for. All right, Connor, so turn your lathe back on.
The button was pressed in.
Turn your button.
There we go.
Slowly turn in because this is an interrupted cut. So you've got 6 edges before you actually get down into where you're cutting. And you're waiting until it's fully formed around. Perfect. All right, so stop feeding in. Stop, no, don't back out, just stop feeding in. We're gonna 0 the X, now back it out. Shut the lathe off. I'm gonna use a caliper.
All right.
Measure the diameter of that slot.
This slot is.
And you're gonna have to use the very end of the caliper.
Yep. Looks like 500.
Gee, so we got it right there because it's a 1/2 inch. We couldn't have done that if we tried.
Yeah, really.
Okay, perfect.
All right. Yep, 500.
Perfect. So now you know you're a 1/2 inch. All right, so we know where that is at 0.
Yep.
So say we want to make a 300 clip, because I don't remember off the top of my head what it comes down to. So say we want to make it 300.
375.
375? All right, we want to come down to 375. We need to take how much off? We have 500.
We want to take 125 off.
Perfect. Come to, you know where this is. Turn your lathe back on.
Yeah, that's pretty helpful.
Run it back into 0. You don't have to be precise because you're going to take 125 off anyways. Now you can go to keep going. You can go to minus 0.125. And stop.
There we
Back
go.
it out. And shut the lathe off. Now we'll see if we got it.
We shall see.
Or if we got it within a tolerance anyways.
We are at a little over what? 395, 394.
Okay, so it was a little slop in there. But by doing that, we can now creep up on it using the digital. This is why I talked about tool part hangout, because there was probably a little bit of deflection in there also, okay?
Yep.
So we're actually very close. We're within 20 thousandths now, less than 20 thousandths now. So we're right in there. This shows what we were after. Why don't you go save the lathe, take the part out.
Okay, I'm gonna back this up a bit. Here's my, I put it right here.
One thing to
There.
note about the lathe, unlike the Bridgeport, the lathe has to be off to change speeds. So once you put it in a gear, that's where it is while it's running. You have to
And
disengage.
there's our part.
Yeah, and go ahead and thread that in so we can show everybody that it works.
Send right here.
There's an Allen
That's really
wrench.
helpful. So I'm gonna start that. Take the Allen key. Find it, there we are. Would you look at that?
Look at that. You made a simulated axle shaft. Good job. Connor,
Yes?
where's your chuck key?
Chuck key was in the what's it called? The chuck. Don't do this.
Exactly. So, again, Connor's been here for 4 years. We all make, some mistake somewhere. That's one that we just need to keep track of. Although we had at least safed it, so electrically it was off, but you never want to leave the chuck key up in there. But you know what? Hey, we all make mistakes. We learn from them, and we move on. So, good job. Do you have any questions, Connor?
I don't, do you?
No, I'm good. I knew what we were doing fairly well. TJ, that's the lathe in the build room. We look forward to being able to answer any questions for you. Stay safe.